Alright, this is your first 9 weeks review for PreCal. This is going to be the first of a few videos. Alright, so number 1 is talking about domain and range. This one's specifically asking for a domain. If you're given $160 to spend on CDs and they cost $15 each, okay, well, we know the most CDs you can buy is 10 because that would be $150. So you can buy no more than 10. But a mistake that's often made is people want to say, well, X can be less than or equal to 10. Well, that's not necessarily true. Less than 10, that could be -8. You can't buy -8 CDs. So we know the lowest value is 0. So we can buy somewhere from 0 to 10 CDs. But again, this implies that this includes every value between 0 and 10, which includes all of the fractions, 1 1/2, 1 1/4, 1 1/3. You can't buy a fraction of a CD, so you can't list it this way either. You have to list out your integers from 0 to 10. Okay, and we can include 0 and 10. So these would be brackets. Okay, so this shows that it's all integers from 0 to 10. Okay, if you wrote out all integers 0 to 10, I would take that for your review, that's fine, but know on the test that it would most likely be written out this way, and it would be multiple choice. You're going to have a few gridables, but mostly multiple choice. Domain and range of this function. Okay, this is a quadratic, so we know it's a parabola, and it's negative, so we know it's opening down. The -4 is not inside the parentheses with the x. It's outside, so this means it's shifted down 4. Okay, so that's going to affect our range because it's a vertical shift. So the domain here, the domain of a parabola, is all real numbers. Okay, there was no red flag here. We talked about red flags if you have a variable in the denominator of a fraction or under the square root. None of that happens here, so all reals. Your range, though, is affected by this vertical shift. Okay, we're, instead of being at the x-axis, we're down at -4. So this value here is at -4. Okay? And it is opening down. So range is your lowest value, so this would be -∞, to your highest value, which is -4. Parentheses, always with infinity and -∞. You can't equal infinity. If there is a value at -4, which there is, you use a bracket. Number 3 asks you to construct a model of this relation and then determine if it's a function or not. Okay, I went ahead and highlighted all of your x values and all of your y values. Okay, the only one of the models that has your x values and y values listed correctly are A and C, so you can quickly eliminate B and D. The only difference from A and C is A says it's a function and C says it is not. The rule for a function means that x cannot repeat. So you look at your x values that we have highlighted in yellow, and none of those repeat. So yes, this is a function. Answer choice A. If you look at your y values here, y repeats, but that doesn't mean it can't be a function. We talked about y cannot repeat in a 1-to-1 function. Okay, but just a general, is it a function? X cannot repeat. Domain and range of a function. This is our absolute value symbols. So this is the absolute value function, and this +8 on the inside is shifting it left 8, and this 4 is being multiplied. This is not a vertical shift, it's not +4. This is a stretch. Okay, so this 4 is multiplying our y values. So all of our y values get multiplied by 4, so it's going to stretch it. It'll become a narrower absolute value function, but it doesn't change that it goes on forever in both directions, left and right. So your absolute value function, if you picture it, is the V. Okay? It doesn't matter where you shift it, those arrows are still there, so your domain is still all reals. Your range, though, is not all reals because you have a low point, your vertex. Okay, now this is shifted to the left 8. Okay, it did not shift up or down any, so it did not change the low point of your graph. It just changed the width, so it became taller or more narrow. So your range, your low point is still 0, and your high point infinity. Okay, they have in your answer choices domain written in interval notation. So you could write, instead of the all real symbol, this would be negative infinity to positive infinity. Number 5 is asking for the inverse. If you're just given a set of ordered pairs, you simply switch the x and the y. So this would be negative 5, 1, 1, negative 5, 8, negative 9. Okay, and that would be the inverse. So that's written f inverse of x. When you're given an equation and asked for the inverse, you switch the x and y and then solve for y. Remember, f of x is y. So I'm going to rewrite this as x equals 3y cubed minus 3. I'm going to solve for y by moving the 3 with the x. So I have x plus 3 equals 3y cubed. I need to get rid of this coefficient by dividing. The entire side gets divided by 3, not just the constant. Okay, and then you need to get rid of the cubed. The opposite of cubing something is to take the cube root. So when we take the cubed root, now we have y by itself, and you need to have that negative 1 exponent to represent inverse. Now your answer choices may be simplified farther than this. If you're not sure about simplifying, you can always check by choosing an x value, say 1. If you plug in a 1, type this in your calculator and figure out what do you get when you input a 1. And then check your answer choices. Input 1 for all of those and see which one gives you the same thing, and that will help you knowing which is the simplified version. For 7, we're going to switch our x and y, so we have x equals 4y plus 6. Move your constant, so I'm going to subtract 6, and then get rid of your coefficient. So my coefficient is 4. The whole side is divided by 4. So your inverse is x minus 6 over 4. Don't forget to have the little negative 1 written there to show that that's the inverse. And for 8, if I switch my x and y, x equals y minus 5 cubed minus 3. Okay, so first the constant moves. And now, before I can move this 5, it's in the parentheses, I need to get rid of this cube. So I take the cubed root. So I have the cubed root of x plus 3 equals y minus 5. Now I can get rid of the 5 by adding it. I cannot simply combine this 3 and 5. This 3 is part of the term under the cube root. So this plus 5 is on the outside of the cube root. So you have the cube root of x plus 3 plus 5 on the outside. 9 gives you a graph of f of x and asks for the graph of negative f of x. So remember, when your negative is on the outside, okay, that's affecting your y values, which flips it over the y-axis. Okay, so which graph is flipped over the y-axis? And that would be D. If you were to fold this along, oh, I'm sorry, I said that incorrectly, excuse me. Flip over the x-axis. So when you flip over this line, it gives you the reflection, which is D. Okay, it changes your y value, okay, which is reflecting over the x-axis. 10 is the graph of f of x is the square root of x that has moved 2 units to the right and 3 units up. Okay, I'm not going to actually graph this for you, but I'll help you by reminding you that moving 2 units to the right is actually inside, and it's the opposite, so that would be minus 2. And then 3 units up is on the outside, so plus 3. So this is what you are trying to graph. Your parent function of the square root is this here. So you would take this graph, and remember this is 1, 1, 4, 2, okay, because whatever your x value is, the square root is your y value. And you would shift all of these points over 2 to the right and 3 up, and then regraph it. 11, 12, 13, and 14 are asking you to graph again. I'm not going to go through and graph all of these, but I will remind you what the equation is. These are the parent functions. Quadratic is y equals x squared. Rational is y equals 1 over x. Square root, y equals square root of x. Cubic, y equals x cubed. And step function is another term for greatest integer function. And in your calculator, you can get the greatest integer function by hitting, so if you want to look at the graph, go to Math, scroll over to Number, and INT, here, number 5, is integer. So the greatest integer function. Okay, and then you could look at the graph of that. Also in Math, I had questions about absolute value. You scroll over to Number, ABS, that's absolute value. Okay, and I'll write that down. That was greatest integer function. All of these should be graphed in your notes in section 1.6. We went over 8 parent functions. These are 5 of them. Okay, so step is just another word for greatest integer. Number 16 is asking about even and odd functions. What you should remember is that a function is even if it's symmetrical about the y-axis. That means you can fold it over the y-axis and it's a reflection of itself. Odd means it's symmetrical about the origin. Okay, that's kind of like the cubic function. The cubic function, if I folded it about the origin, which means over y and x, it would be on top of itself. Okay, so this one in number 16, its line of symmetry is the y-axis. So this one is even. And y would be because it's symmetrical about the y-axis. 17, also odd, even, or neither. This one is neither. It's not, if you fold it over the y-axis, it does not reflect itself. If you fold it over both, it does not reflect itself. So your reason would be because it's not symmetrical about the y-axis or the origin. Okay, 18 is asking you to graph. I'm not going to go over the graph with you, but this is absolute value, and it is shifted to the right 4, because inside is opposite. So the absolute value function is normally on your xy axis here, and it normally is even. But once you shift it to the right 4, it's no longer even. It becomes neither because it's not symmetrical.